Hello.
Yes, sir.
Yeah. Okay. Yeah. Okay. So fine. Let me quickly draw something and convert it to isometric view or all the views for that particular object, and then we'll see how it can be put into the sheet. So let me take this image over here and just quickly drag it over here. So yesterday we discussed, right? You don't have to go to insert and all. You can just give it anywhere, and you can give your scale factor. And if you want rotation, you can give rotation also. But normally you can just drag it up because I'm not using this as an object for. I'm just using it only for reference. That's right. So first, let me draw this front view. Based on that, let me draw the side view and then the top view that will be in the bottom. So because this is a first angle projection, so you have your front view, and below that front view you have your top view, and the left side you have your right side view, on the right side you have left side view. But for this, if I have the three views, it is more than sufficient for me to reproduce. So I'm just checking my units. Uh, okay, it's in millimeters, so our drawing will be in millimeters. So let me just quickly, with this reference, let me just quickly draw some lines. So here, I'm just trying to be parallel to that. Let me turn on F8 and say, let me give a distance of 2000. And this height, I just want it to be, say, 500. And this distance is there, right? So whatever is there, 2000 minus 500. So that will be 1500. Enter. And here also same. So this distance minus this distance, that will be enter. We have our 500, enter. It will close. If we are correct, it will close. So it has closed and we got our front elevation. I'm just taking a rough dimension. And then what I'm going to do is now I'll just draw a parallel line to this, like this. Here, because I'm drawing the side view, what I do is I'll just take L enter, and then just I don't click over here, but I'll just drop my cursor over there and drag it from there. I'll have a what you call reference line, which indicates my parallel, whatever the point I am taking that point as a reference. So let me give my distance. What will be our side view? Like if you're seeing from this direction, our maximum height will be 2000, right? So that's what we are seeing. Like for this object, we try to see from this direction, what we're going to see, we are going to see this merged in this surface, and looks like this. And the maximum height of this in this direction will be this length. So first, let me draw that length. And one more thing is, so we are going to see this merge to this thing that will be appear as a line over here. And also the maximum height is this thing. And how do we know? Okay, we got height. And how do we know length? Length is same. Whatever the length we are taking, we can take that same length. That because we don't have any length mentioned over here. See, from this front view, we cannot actually measure the width that we are assuming. And here in this case, I'm giving the width also the same. I'll just go to L enter. First thing is we know height. The height I'm going to give as 2000. And this also I'm imagining as 2000, which is not there. The next thing is you have to draw a line parallel to this line. Just take this line as a reference, give you a third click, and give you a fourth click. So the only thing that is balanced is you have to show this part, right? This part, we can take this line as a reference. I'll just drag it over here and drop it like this. So I have my reference line like this. Let me just okay. Now the balance part is we have to draw top view with reference of front view. Okay. what is the information we are going to get from for the top view from front view? The maximum width, that is, this distance is going to be equal to this distance, right? Can you follow me? So I'll just draw a line like this. Here also, I'll just say 2000, and this distance we know is going to be this distance. I'll just drag something like this. I'll take a point in this direction. You can drag anywhere, and then the rest you can trim. PR, enter. You can trim whatever the line that is not required. So we have to have represent this part. If you're seeing from the top, let's say this is front view and this is top view, we have to represent this part. How do we achieve that? We can just take this line as a reference and draw something like this. Until now, we are clear. From one view, we can generate two other views also by taking some of these inputs. Without any inputs, we cannot draw. We can just get one or two dimensions, but the rest we have to have in other views also. Now we have drawn side views, top view, and front view. The only thing balance is we have to draw isometric view. Yesterday we have seen how to draw an isometric view, right? Let me redraw this in isometric view. So in order to draw something in isometric view, you have to go to the isometric environment that is present here in the isometric crafting section. If you turn on this isometric view, this you can go to any of the isometric plane, top, right, or left. So I'm checking top because you have to always think in a way that which is the first thing you are going to draw in this view and what will be the easiest method. For me, I think if I draw this bottom plane, like in this bottom rectangle, I'm going to take and then offset that and give the distance. Then I have to carry like that. So that's what my thinking is. Let's see how this proceeds. This is what our bottom plane is. I'm just taking polyline, enter. Then I'm switching on F8, which means I'm turning on ortho, so I can travel in only one direction. You can see this is the direction I'm trying to travel. I'll try to give the distance of 2000. That's what we took. So the next direction also 2000. The next direction. So it's in orthogonal view, orthogonal draft mode. That's why it is not traveling any other direction. It's only traveling in the direction that is highlighted over here. You can see green and red, right? That is what the direction it will travel. So we have got that. Now the thing is, I have to copy the same thing with the height of the height we have given here is 50, right? So I have to copy that to 50 mm. CP, enter. Now, if I try to copy, it will only travel in the XY plane. So, for example, if you want to make it travel to YZ plane or YX plane, you have to toggle between the views, planes. For that, either you can select over here or you can just press F5. CP, enter. Now, select the object. Either you can press that or you can press F5. Now you can see I'm toggling between the planes. So I'll just confirm this plane and the height I am going to give it as 50. You can see I have given 50. Sorry. Let me confirm DI. So this is what the distance is. Let's measure 500. Sorry. My bad. I'll just CP enter. I have to copy this to 500. Enter. So we have done one copy. So we've got this surface, but is it correct? No, because we have to have a partition over here. That partition should happen 500 units from this distance. Okay, that's what we know. First, let me connect all the edges. I'm drawing L enter and then just escape spacebar again. That command will continue wherever we left. We have our cube. So we have our cube. Now, so this is what we got. And now for this cube, I have to draw a line 500 units from this end, right? So if it is 500, it should be 1500 from this end. Let me draw a line. Just take L enter, try to scroll. If it is not visible, okay, there is one more method to draw. I'll just extrude this, explode this thing, X enter. Okay, this is of, I want to see the properties of this line. Where should I go? I have to go for PR, that is properties. Whatever the object you are selecting, if you want to check its properties, you have to select PR and then select that particular object. You can see all the properties like what is the layer of that particular line or circle, anything. And also, if you scroll down, you can see the length. If it is in an angled position, you can see its angle also. Okay. What I'm concerned is 2000. That is the length. So if I want to divide by 2000 by 500, how many times I have to divide? Like what is the number? 4, right? So I want to draw a line here. That distance should be of 500. Okay. For that, what I'm trying to do is I am trying to divide this particular line into 4 parts. 1, 2, 3, 4, each of 500, 500, 1000, 1500, 2000. So in that way, I can draw a line by taking 500 as a node point. So here you can see it is easy to draw a line in between, that is 1000. But if I want to draw at 500, it is somewhat difficult. All right. So I want to divide this particular line. What I can do is I have to press this divide command, select that object, and I am going to make it 5 parts. So you can just give the number 5 because starting and ending. So you can check this line will be now divided into 5 parts. Let's see. I'll take L enter. As soon as I go to any particular, you can see 1, 2, 3, 4. Right? I have divided this line in 4 parts. I'll just draw a line from this direction to this direction. And now the bottom line. So we have seen the concept of selection planes, right? That is useful over here. There is a line, this line, and there is a line over here. So this one I want to remove, but it is joined. What I'll do, select this particular rectangle and press X enter. It will be exploded. Now it will be of individual components. Now, anyway, this will not be visible here. This part is not visible in the drawing also, right? Here it's not visible. So what I try to do is I'll just delete this line. Now I have only this line. All right, I have only this line, and upon this line, I have to draw like this. Are you following me, guys? Is it confusing? Anyone? Is it confusing? Hello? Shall I repeat?
No, it's fine.
Yeah, okay. So these are my 4 points. And okay, I'll just try to erase certain things so that it will be easy for us to follow. So this will be my, say, front portion. This is what we are going to look, and this is what our extrusion is. In this particular area, it's not going to be visible. I'll just try to erase this line. So now it's clear. This portion, we are having one line. Now I have drawn this line for me to have a reference so that I can cut. So until where I'm going to cut, until the whole end. Okay. So then what I'm going to do is I'll just, we have drawn a line. So from here, we have to have another line. That line should be 2000 minus 500. We are going to have 1500, right? So that line should be of 1500 mm. I'll try to draw 1500. And that should be copied the next direction now also. CP enter. That should be copied all the four corners. All right. Now the only thing pending is we have to connect the four corners. Okay, we have connected. Now we have to clean up the drawing a little bit so that it is less confusing for us. PR enter. First, let me remove this line and this line, this line, this line. So you're getting the point, right? So this line, this line. You can see this is exactly of what it looks like, right? This looks similar, right? Except for the dimension, whatever that is there, we have an L-shaped object, we have an L-shaped object. So by having this front elevation, side elevation, and the bottom elevation, we have tried to project this in the form of isometric view, and we have projected isometric view. So as soon as we have done in the isometric view, we have to come back to our normal drafting view. How do we come back? We have to switch off this isometric drafting view. That's it. We will be back in our normal drafting view. So after we are done with this projection or the sample image, we can just select that and delete it. So it will be gone. Okay. So now we have our drawings. The next thing we have to do is we have to annotate these things. So just go for annotate. The dimension, you can just take align dimension or linear dimension. Yesterday we have seen this also. I'll just give dimension like this. If your dimension is very small, what you have to do, just go for density and then just go for modify. In the modify, you have to increase the scale value. Let's say I'm increasing to 30%. Okay, set current, close. You can see the dimension values increase. The same way, I'll just select align again. I'll just press F8 so that my orthogonal view is turned off. We have two dimensions, okay, this and this. So if you want this dimension also, press spacebar. You'll have align one more time. Just the dimension. So we don't want the dimension in this style. So we are going for DIM ED timer, that is dimension edit. After that, you have to click that oblique. So once you have clicked oblique, you have to represent the way in which your dimension has to be in the isometric view. This dimension, I want to be flown in this direction. So I'll just click that and I have my dimension in that direction. So this dimension I have to give in this way. So I just select the dimension, DIM, timer. You have to click oblique. Let's say I am going to give the dimension in this direction. So sorry, this is the direction I want to give. Oblique, and you can select this dimension in this direction. So you have the dimension in this direction. Dimension. So this is direction I want to give in this direction. So we have our three dimensions in proper representation. And also there is one more point over here. There is something called dimensions in annotation. So we have given dimensions in annotation. So the point to note over here is whether we want to change the dimensions when we change the scale. Whatever we have drawn until now, it is in the form of 1:1 scale. So you don't have to change your scale over here. This is what your drawing space is. That will affect automatically when you go for your model space to paper space. We will see that once we go to paper space, what is the changes we are going to see and all. So I think you guys are clear. You can just form your views, and with this plan views, you can just form an isometric view. Now our task is to represent this isometric view in a
Excuse me, sir.
paper.
Excuse
Yeah,
me, sir.
yeah,
Always draw while drawing the isometric view. Do we have to take the angle up by 30 degree?
that is for representation purpose. So if we combine the three angles of any isometric drawing, that should be 180 degrees. Okay.
Okay, sir. Okay, sir.
Okay. And we take 30 degrees because no matter how much you take 30 degrees or 60 degrees, it is way better when you draw 30 degrees. Like they have tried everything, and if you draw something in 30 degrees, that looks uh, very easy to add the depth. So here we have our length, we have our breadth. So if you are trying to tilt 30 degrees and give your depth, it looks better. That was the only reason. There is no other reason. You can take
Oh,
60 also, okay? But if you take 60 degrees, like it'll land here. Let me show. I'll just arrow enter. I'll just try to rotate this like this. Okay. Now you see the same object. How does this look? Like it is way more rotated, right? If you try to look this object. So that is why they have decided if we draw something in 30 degrees, it looks better in visualization.
okay, sir.
So that was the reason. Okay, now we have to project this whole drawing in sheet. Most of the Indian companies, what they do is, you know about title block. So I'll show what title block is. First thing is, let's see, you want to print this thing. The easiest way to do is Control P. Just select continue as a plot to plot as a single sheet. Now you have to give your printer name. If you don't have printer name, just leave it. And if you want to convert this DWG to PDF, select AutoCAD PDF. If you want high quality, just go for high quality. That's the first thing. The next thing is you have to select your paper size. So here is what our technical differences are, industrial differences come. If you're from manufacturing industry, A4 is more than enough because most of the drawings will be fitting in that particular A4 paper. But if you're from construction industry, people use A3, size A3. In the A3 also, is we have architectural A3 and ISO A3. These are completely two different standards. This depends organization to organization. Whatever if you are following ISO, you can select ISO standard. If you are practicing international architectural standards, or if you are using ANSYS standards, you have to select your paper size based on the standards you use. Now let's see, we are using ISO A4 size. So there are two types of A4 sizes over here. One is horizontal, the other one is vertical. You can see over here. This is vertical dimension is more than the horizontal dimension. Okay, that you can see over here. A4, right? A4. Sorry, yeah, here 297 across 210. So the other dimension is 210 cross 297. X is 210, Y is 297. If you select this, X is 297, Y is 210. This depends as per your drawing and as per your title block of your company. Some has a horizontal title block, some have a vertical title block. Let's see vertical title block later. Now let's select the paper. After you have select the paper, you have to select the type of plot you are going to use. Are you going to use the color or are you going to use black and white? That you can select over here. If you are using color, just select none. If you anything that is the color, and if you have a printer of color, you'll get color. But if you are going for say black and white, you can select grayscale over here. Okay, so that's how you select your like color of your print. And then the next thing you are going to do is you have to select the place which you have to print. There are multiple ways to select the thing when you are drawing or when you are printing from the model space itself. You can just go for window. So then you have to give whatever the thing you want to export to PDF to DWG. So let's say I want to export this whole region. Click it. And then after you have done with all the settings, you can just go for preview. You can see some of the parts gone because we did not select properly. So that is why the preview option is there. You can just select go to window, and you can just click the window here. You can see this is what a window looks like. Now you can just go for preview. Still there is an error because the paper size which we took and also the selection which we are taking is not matching. So let me just change the size to, let's say, 810, 210 by 297 with the same window option. Now let's check. You can see now the object in this direction is okay, but the objects in the below is not visible properly. We can just go for window again, or you can just deselect this fit to paper if you have the scale with you. If you don't have any scale, just select this fit to paper. No problem. Like if you're having trouble with the method which I have shown, we can just go for extents. So it will show whatever the extents of your object is. We have set the limits right in the beginning when we were discussing. So whatever the limits of your project is there, it will select. So mostly we'll go for window, like, or if you want to print whatever that is in the display, go for display preview. So you have your object here, and the whole paper is going to be wasted. So that is the main drawback of display. So let's say I just want only one particular drawing. Only this particular object. You can select like this. We go for preview. Only that drawing will be visible. Okay, but most of the Indian companies will use only this. The only thing that is missing is I want to have a title block. What is title block? Title block is something which displays all the other properties. Let me just have an example. I'll just. So this is what title block is. Title block is you can imagine as a border of your drawing, and this border has certain information like what is the drawing name and what is an if at all it is having any corrections, that is called revision. For example, what revision is? I am a draftsman and I've drawn something, and I am giving it to my supervisor, and the supervisor has some changes. That changes will be noted via this revision cloud, and then I will correct that drawing again, and then I'll send that drawing. That will be called my second revision. So that will follow until the drawing is perfect. So you'll mention what is the number of revisions and what is the name of your project, who is the client, what is the title. This will be changing from company to company. This we have you here horizontal. Some companies may have rectangular title block also, and also name, the date, the draftsman's name. Here we have architect, like that. You can have draftsman's name and the company date and all the things. Yeah.
No, once more, please. I didn't. My correction was lost. Once more.
Okay. I was explaining about title block. What title block is, and how you can. This will be depending, or this will be changing from company to company. This thing you have to do only once. Like dynamic blocks, you try to draw the title block only once, and you'll say somewhere. And after you're done with your project, you can just save it like as a copied. You can copy from there, paste wherever you want. So that is what a title block is. So in the current scenario, our title block is way bigger than our like way smaller than drawing. What we can do is either you can decrease its size or increase its size. I'll just go for SC scale, give any point. I'll just draw something like, because we are just having a reference, right? That's why I'm just trying to increase or decrease the scale. So this is what your 3D view is. I just select everything. I just drag like this. The size will be increase or decrease if you scale. You have to be very careful of that because it's a reference. I'm just trying to draw. So here also I'll deselect everything. I'll try to minimize its size in 3D. For something. to move. Oh. Just press Control. Press Shift and deselect. So you'll be deselecting whatever the things you don't require. So yeah. So let me resize this again. Press SC, enter, like this, and you can. So SC, enter, something like this, so that it will fit. You can name also. I'll just show that one also, like this. You can place everything over here, and you can just go to text, multi-line text. You can say like draw here. This is your. So this will not be like this normally because you have your standards, but since I'll scale this one also like this. To this is our top view, and this is the side view. This is isometric view. Outside view, isometric view. So this is what our views are. Now let's try to print this. Just go for Control P, continue with single sheet. Now you have to select the AutoCAD PDF high quality print. Okay. Now we have to select our sheet size. So let me select this 297 sheet. I'll go for window. So let's say I'm selecting this window. Go for preview. So I'll just go for window again. Let me select from here to here. Let's see what the preview looks like. So again, we are not getting what we want. So I'll just go for window again. Select this area. You have to manually do this because the scale we have selected is a random scale. If you are selecting the proper scale, you can, instead of fit to paper, you can just give the scale. Okay, now I'm just giving 1 mm is like say 39 units. Let's see what happens if I give scale. You can see there is a change. The changes in the increase or decrease in dimension. So let's say I give a random scale. So 1:2 or 1:4. Let's say 1:2, and then let me go for preview. So let me just go for window only and select this end to this end preview. Just refresh, that is RE enter. Now go for Control P, continue to plot sheet. So we have to select PDF, and then you have to select your paper size. So in the PDF options also, this I think you don't have to enter anything. So I'll go for window over here, and I'll select my window from here to here. Go to preview. You can see you'll get something like this. If you want to continue with that, you can just go for apply to layout or OK. Then you have to give the location. Whatever the location you give, your PDF will be saved in that location. So you can see This is what your formation is. But it is not good. Why? Because we did not do this in layout. But most of the Indian companies will be doing this and they'll be okay with that. So let's say if you want to change the size of this PDF, since we are not printing it anyway, let me just go for Control P, continue plot. I'll just select ISO A3 size. Okay, now I'll go for window. Let's see what happens. Okay. So you can see even for ISO A3 size also it's taking like this because we are printing from the what you call model space itself. So is there any other way? Yes, there is other way. That is you can print from the layout space. So the advantage of layout space is you can have much more precise print. So as you have seen, model space has some limitations. Yes, you can control P here also, but it has certain limitations. That is why AutoCAD has created a separate environment for our plotting. So how do you go for your plotting is you have to go for your paper space, which is also your layout. So if you're in model space, you don't find anything anywhere you don't find the settings for your layout space. So in order to achieve that, you have to go for your layout. So here, once you come to this layout environment, you will have your layout tab. So if you click on the layout tab, you will have the settings that is related to our layout. So this is a simple layout. And you can see a boundary box over here, right? This boundary box actually is dependent on our page setup. How do we, once you select this layout, you have to go for page setup. Whatever we have seen before, once you press Control P, that will be there over here. Just we have one layout that is already done for us, or you can just go for new also if you want your setup as a new one, and then you have to give our like requirements. Let's say I am going to have AutoCAD PDF format, and then you have to here also you have to give your what you call paper size. So let me just give a paper size. And what do you want to plot? You want to plot a window. So that window is our window. This is what our window is. So then after you're done with all your settings, you have to hit OK. So this is what your setup one, set current, close. So this is what your page is. We have set up our page. How did we set up? We have gone for page setup, right? After that, there is no view, right? There is no drawing over here. How do you import the drawing here? So once you have gone to layout, you have environment, you have to go to this layout tab, and then we have to insert our view with this options. I'll go for rectangular option first. Let's see what happens. I'll just place my rectangle somewhere like this over here. Now you can see whatever that is there in the model space, we can see over here. So this particular part is going to print in our paper. Now let's check it. So you can see the tab is visible without me selecting anything. This is exactly going to fit in our project. Now, let me just take a window again. I'll take from here to here. Let's say preview. You can see now it is much more clear. Once when I've taken something in Control PA in model space, you can see the page is not even full. Now the page is filled with the exact way I want. So top and bottom, any drawings you'll see it will be left empty. And from the border which we have till the title block, till the drawings, everything that is as per the way which I wanted. You're getting my point? That is the use of our model space. So there are multiple what you call ways to represent this model space also. That is like say I want to have all my plan views in one page and I want to have my isometric view in one page. How can you do that? I'll just go for this place. I'll first thing is I'll just copy this thing or move this thing somewhere like this here, and I'll copy this thing, everything, CP enter. I'll just move here. Now I have isometric views in a separate in my model space in a separate area. I want this sheet as a separate sheet, only isometric views. All the planes, all the plans should be in a separate sheet. I'll just use some space like this. I want these plans to be in a spacious way. Now I'll go to layout 2. You have this option over here. You can increase or decrease your space like this. And one more thing, what you can do is we have talked about annotation scale, right? The scale, once you double click on this viewport, it will be in our model space. No, you shouldn't double click that. You have to click only once, and then there is a scale option over here. It will be reduced to random number. So if you want to increase the size, you have to just press 1:2. It will be decreasing the size scale. Like 1 unit is equal to 1 unit. If it is taking 1 unit and it is reduced by half, it is called 1:2. Let's say we want to double the size of this isometric view. I'll just take 2:1. Now let's see how much it has grown. So that is not fitting in our what you call viewport. Even if I increase the size of the viewport also, like that you can increase the size. So again, what I'll do, I'll just double click. Sorry, I'll just increase in the view. So I'll just single click. I'll just take 1:1. Let's see. This random scale, whatever the scale we have taken, it is going to occupy the whole thing. But we don't have any space for title bar also, which means our drawing is somewhat big. So this is how you have to select the scale. So normally there will be no standard for scale in manufacturing because it will be 2 dimension, which is 1:1. Scale will be at most useful for construction drawings, which will be very big. So if a drawing is of 10 feet, we cannot have a 10 feet long paper. So we'll scale it out. So here I'll just try to scale it 1:1. Let me give like this. So you can see if I select this particular scale, it is viable for me to represent the whole drawing in this particular sheet, the isometric thing. So I'll just check with the borders also, like this. And try to move. So you can see, if I select this scale, I can view my isometric view. Only I can represent my isometric view in this given sheet. So let's Control P and see what happens. So ISO is 4 is okay for me. I'll just select window. So I want to print from this to this and select AutoCAD PDF preview. You can see the page is being selected and I have my isometric, only isometric view in the current view. All right. So that is what our model space and paper spaces are. Whatever we are going to draft, we have to draft in model space. And then when it comes to printing anything, you have to select the layout space first. And then you have to give your shape in the form of rectangle. If it is an uneven shape, you can check the polygon or object also if you're having some uneven shapes. like the image over here, if your drawing is in this particular shape, you can have polygonal shape also. After having your shape, you can drag your object as per like, for example, if I click on this, just click one more time. Now you can see you can increase or decrease the scale here also, but I don't want that. I want to increase or decrease the scale over here, or I want to say by moving, I want to take that isometric view in this particular environment. You can just operate from here and take that scale over here, like take that image over here. What we are trying to project is, if you are in the paper space and if you want to go back to model space to bring that element in order to adjust and like this will be your printing area. Whatever you are presenting in this printing area will be printed. So you have to fine tune and adjust this printing space to whatever we are assigning. Let's say this layout is especially dedicated for our plan views. So we have to give all our plan views related information in this space. After that, you have to double click and then select this view and we have to lock it, because it is very easy to unlock and lock and change. So in order to restrict the changes, after we have done with the view and we are satisfied with whatever that is present in this particular view, we have to lock it. And then we have to go to this next layout. We can add multiple layouts like this. Whatever your drawing is, like how much ever big your drawing is, you can add that many layouts. So we have a requirement of 2 layouts over here. So after that, this is satisfactory to me. The changes are, then I can just select that viewport, lock it so that no further changes are possible. If you want to make further changes, you have to unlock it and then you have to change it. After that, let me rename it. This I'll rename it as plan views. This I'll rename it as isometric. Isometric. Now we have got our 2 sheets. If you don't want this sheet, just delete this sheet. That will be gone. So we have a plan view, we have isometric view. So we have reversed it. So we have isometric in the plan. Just try to rename. And you want to jumble also, it's possible. So okay, so in order to like, you can take this thing over here or move these tabs, just like a tabs in a browser, you can move it anywhere. This is a plan view. Let me rename it as plan view. So if you want to remove something from your plan view, just as we've discussed, you can just reduce the size of this viewport, or you can just click on this viewport and just try to double click on this viewport, unlock it. If it is locked, then just scroll it down and just fit it whatever that is required for you, like this. And then you can just lock it. Like if you want to increase the size, what you can do is you can scroll like this. All you have to do is just fine tune it, like how much ever is okay for you. If you think this is okay for me, and then after finalizing, you have to lock it so that it will not move. Just don't concentrate about the scales right at the moment, because scales are very important. But when you're practicing, you just forget about the scales. After you practice something, you have to represent this drawing in a manner that whatever the scale we are taking, that scale is in view with our company standards. So because if you talk about architectural, I don't know much about mechanical, but when you talk about architectural industry, there are only 3 type of scales that people use mostly. That is 1:8. The other one is, it is in mm, so we are not having that other scales. 1:1/8. The other one is 1:1/16. The other one is to 1:3/32. There are 3 major scales that is used in the construction industry, depending on your size of your drawing. these three scales are repeated. But when it comes to mechanical industry, most of the times we used to use 1:1 only, because whatever the dimensions we are going to play, that will be the true dimension. Okay. So I just wanted to cover one more option, that is a latest addition to this AutoCAD. I'll just try to close these things. Okay. I'll try to open one drawing. Let's say I have a drawing over here. This is done by me, let's say, and this is done by me yesterday. And I have taken the same drawing with the inputs from my client, and I have given certain modifications to this drawing. And by looking by glancing it, I'm not able to figure out what are the changes I have made in this drawing. Like that is the current version to the previous version. What are the additions I have made? I'm not able to see. So AutoCAD from 2019 has provided a beautiful option. If you come to so, so if you come to your view, you will have something called DWG compare. So with this DWG compare, what you can do is, the shortcut is compare. You can actually compare what is the latest addition in comparison to your previous version. So this is my latest version. Let's say I just go for DWG compare, and I want to compare this drawing to a previous version drawing. So this is 1, 2, 3, 4. I'll just check in 1, 2, 3. That is my previous version. As soon as I open, you can see there is a highlight area over here. So which means this drawing has a modification in this given area. So whatever that is there earlier, that is not there now, or whatever that is not there earlier is there now. So that is the advantage of PWG compare. Let's check. I'll just go for 1, 2, 3, 4. If I cancel this, I'll be in my 1, 2, 3, 4. Or let me open my 1, 2, 3, 4 again. Let's go to that area, that particular area. Right here, you can see this is what that area. I have made certain changes in 1, 2, 3, 4 that is not there in 1, 2, 3. That is why we have highlighted. So where do you access that tool? That tool can be accessed in our view, DWG compare. Let me show that again. Just go for DWG compare. Select your previous version of the same drawing. So this tool, what it does is it will compare the previous versions to current version, and it will update me or highlight me where the changes has happened. So here, this particular portion, this drawing doesn't have, or the previous drawing doesn't has something in this area. This drawing doesn't have. So that is highlighted, and that can be accessed by us. Once you finished with that, you can just try to finish it off. That will be gone. So you don't have to worry about the previous version once you get notified. So you can give it a comment, or if you want to send it to someone, you can just mark it in the form of revision cloud and send it to them that this is what area is, and this is where the change has happened. Please note down. Like that, you can just give a comment. So the one more concept I wanted to tell is external references, or XREFs. So external references is something. Say you are drawing a project and you want some external help for your project, like we have gone to insert and imported PDF, right? For our project, we have inserted images also. What if you want to attach one more drawing to our project? Say we are drawing a huge building, and some part of the building is already completed, X part, and we are going to attach that X part so that we can complete our white part and we can have a whole project together. That is where our XREF will come handy. So XREF is nothing but external references. So if you want to add some addition to your current project, which is also a DWG, you can give in the form of xrefs. So if you want to add xref, just type xref. You'll have your xref panel. Whatever the external reference we are going to take, that will be present over here. And if you want to add one external DWG file to our existing AutoCAD, just go for attach. So you can see we are not importing the whole project. What we are trying to do is we are trying to attach so that it acts as a reference for us. If you want to import, we just open something like this here, select everything, Control C, Control V. We have our project, whatever that is there in that project, we'll have. No, we don't want that. Like if you import, the file size will become bigger and it will be very difficult for us to manage. So what I'm trying to do is I'm trying to attach this 1234 file itself in my drawing tool. How can you do that? You can do that by going to Insert, Attach. So you have 1234, select that. Once you select that object, it'll ask whether you have this in the form of attachment or not. We are okay with having this in the form of attachment. And then if you know the scale, you can just give the scale. Right now, I'm just leaving it as it is. Hit OK. And you have to give some reference point wherever in the project. Press Enter. Sorry. Once you give your reference point, you will have your xref. So this is where your xref will land. Once it is there, you can move your xref wherever you want. So, okay. And based on this, let's say I have completed until this. I want to start from here. I'll just start from here. Whatever that is on top of it. This is also useful for all other disciplines. Once an architect completes his project, you can just take his project and you don't have to draw once again all these columns and roofs and all. You'll just have this as an xref. And if you're from, let's say, structural engineer, you can just simply place your column. Let's say my column will be in this area. You can just simply try to represent like this. Like this. So once you take this xref out or move it, this xref will stay as one block. So it's easy for us to move. If you want to move this, the moment it's stuck. But if you want to move that, it will move. One more thing is to notice this xref always has a path. Okay, you should never mess with this path because our drawing, let's say we have completed this drawing. Let me save this drawing. I have issues with my keyboard, I guess. Okay, now I'll try to save this. AA. We have drawn something and we try to save this AA. Let me close. And our xref is 1234, and that is in the desktop. Okay. Now let me select this and move to some other folder. Now let me open that AA. Let me close this. Now let me again open drawing. Where is that AA? Just try to open. So you'll have an error message. So you can see we have changed the path of our xref, right? Once you change the path of our xref, you will get notification that your xref is not located. Just try to ignore first. Then go for xref. After that, so this is what your xref is. You can see there is a danger symbol over here, which means your path is missing. Just click on this xref and try to browse it. So you can see it is located earlier on desktop. Now it is not there. Just give your new path and select open. You can see the xref is always automatically present again. Let me close now. Let's again open this AA file, open. So as soon as I hit file, you have your AA present automatically. So open the if you try to open the xref, if the path is not found, what you have to do is select that path, and you have to give where the location of that particular path is. New folder, open. So you have your XREF. So that is what our XREF is. XREF is nothing but we are trying to give external reference for our drawing instead of importing that, because we want to save our size of AutoCAD file. If you try to import everything, our file will be very big. So we want to save that space. So that's why we are trying to attach the drawing, not copy the drawing. How do we do that? We just go for insert, just go for attach, and give the drawing wherever you are, wherever it is, the file location. The one thing you have to be careful is where the file location is, and you have to always remember that file location. In a hurry, you can attach any drawing, but once you try to forget or change that file location, path location, you'll always have this error message once you open this current drawing. So you have to always be careful of where your path location is, and you have to make sure that the path is not changed. So if even if it is changed, just go for XREF and double click on this, and you have to give where that location is. With double click, you can know where that path is. If you are not having the error message, or if you're having, sorry, error message, click on that path and change the path if you know where your file is. Okay, so that is what XREF is. I think with this, we have covered almost all the topics that are present in 2D environment. Tomorrow is the last class. I will try to cover the introduction to 3D environment. What are the basic stuff that we do in 3D environment? With that, I think we'll complete our AutoCAD syllabus. So first, let me minimize and try to stop the recording.